Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. Now, since this line happens to be inclined to both the reference planes, so neither of the front view or the top view, they will be parallel to the XY reference line. And we are not going to obtain the true length of the line in the front view or the top view projections, and the projections which are available on the horizontal plane and the vertical plane, they will reveal the apparent length projections of the given oblique line. And in case we are required to evaluate the true length of the line as well as the true inclinations of the line with respect to the two reference planes, then we need to deploy the principles of the rotation of the line method in order to evaluate the true length and the true inclinations. So here we have got a real life situation which we have to convert it into the projections of the oblique lines, and once we convert this real life situation into the orthographic projections, then we will be using the principles of rotation of the line in order to evaluate the true length of the line which is available with us in this particular case. So here we have been provided with, here we have got a real life situation into which we have got two oranges available onto the tree which are lying at different coordinate locations over here. So here we have got a wall, and these two oranges, they are available with us onto the different sides of the wall over here. So this is the front view projection of this situation, and we can see that this particular location of the orange number 1, that is the first orange, it is located at the height of 1.6 meter above the ground and 1.2 meters on the left side of this particular wall. So this is the location of the orange number 1, or the first orange which we have labeled as orange A, whereas there is another orange which is available with us onto the other side of the wall at a linear distance of 2.6 meters measured alongside the wall over here. So this is the distance between orange A and orange B, and this distance is measured alongside the wall. So since we are going to look at this from the front side over here, so this distance we will be able to view from the top view projections over here. So regarding the coordinate location of the orange number 2nd, so here we have got orange B, which is located at a height of 2.8 meters above the ground. So we can see that on the other side of the wall. So we have got orange number 2nd or orange number B, which is located at a height of 2.8 meters above the ground and 2 meters away from the wall. So we can see that two oranges we have been provided with. So these are the coordinate locations over here. So the width of the wall happens to be 0.3 meters over here. So this is the width of the wall, 0.3 meters, and we have to locate the actual distance between these two oranges in the front view projections as well as into the top view projections over here. So once again we can see that here we have got the front view. So from this side we have to look at this particular situation. So in order to draw the orthographic projections of this particular real life environment problem over here, so we have to assume a scale of 1:50. So scale of 1:50 means a height or a distance of 1 meter will be marked as 2 centimeter or 20 millimeter into the orthographic projections over here. So as we evaluate this situation, so we can find that into the front view, so here we have got wall which is going to have a thickness of 0.3 meters on one side of the wall at a distance of 1.2 meters on the left hand side. So we are going to locate the coordinate location of point A at a height of 1.6 meters above the ground. So point A will be located. Similarly, in the front view, on the other side of the wall, that is on the right hand side of the wall, the point B will be located at a height of 2.8 meters above the ground and at a distance of 2 meters from this wall located on the right hand side of this particular wall. So this way the front view projections A dash and B dash can be located. Similarly, the top view projections of this particular object, that is two oranges A and B, will be located, and once we are able to draw the front view as well as the top view orthographic projections corresponding to these two objects, then using the principles of the rotation of the line, we will be able to evaluate the true distance between these two oranges over there. That is true length of the distance between orange A and orange B. And these two oranges, we must remember that they are available with us on the opposite sides of the wall. So this true length we need to determine using the principles of the rotation of the line. So let us start with the construction of the orthographic projections corresponding to this real life situation over here. So we know that the XY reference line we need to draw to begin with. So once we draw the XY reference line, now we can check over here. We have to draw orthographic projections looking from this side as a front view. So if we are going to look at this environment or this situation from this side, so here we have got this wall. So the thickness of the wall happens to be 0.3 meter. So using this scale, this thickness we are going to draw as 6 millimeter over here. So we can see that this is the thickness of the wall, which we have mentioned as 6 millimeter. So once we draw the thickness of the wall as 6 millimeter, now using the coordinates corresponding to the point A and point B over here, we will be able to locate the coordinate locations of the A dash and B dash points in the front view elevation projections over here. So now we can see corresponding to this wall, orange A is located on the left hand side at a distance of 1.2 meter away from this wall. So at a distance of 1.2 meter on the left hand side. So 1.2 meter means that this is a distance of 24 millimeter away from this wall and at a height of 1.6 meter. So the height of 1.6 meter means that 32 millimeter above the ground. So we have to mark this distance of 24 millimeter on the left hand side, which corresponds to a distance of 1.2 meters on the left hand side. And from here we have to mark a distance of 32 millimeter above the XY reference line or above the ground over here. So this distance of 32 millimeter corresponds to the height of 1.6 meter. So this distance of 1.2 towards left and 1.6 meter above the ground, it is going to provide us with the coordinate location of point A dash in the front view. So corresponding to this orange A, so the location of the point A dash in the elevation has been located. Similarly, we will be using the coordinates corresponding to the point B. Now we can check. Point B is located at a distance of 2 meter on the right hand side from this wall. So 2 meter means we have to draw a distance of 40 millimeter on the right hand side of this wall. So 40 millimeter towards right side distance we have drawn, and then the height of this orange, it happens to be 2.8 meters above the ground. So this will translate to 56 millimeter above the ground. So we have marked this distance 56 millimeter corresponding to 2.8 meters above the ground. So this way the coordinate location of point B dash as well as A dash, they have been located, and the moment we obtain the coordinate locations corresponding to the points A dash and B dash. So we need to join them using the black line, which is going to represent the apparent length projection corresponding to this particular string, which is going to join the points A and points B in the elevation. Now, having obtained the front view elevation projections of these two objects over here, now we are going to proceed with the construction of the top view projections of this particular situation. Now, in order to draw the top view projection, we can see that from this end, the distance of point A, it has not been provided to us. So we can assume any suitable distance from the vertical plane. So we assume that there is a vertical plane over here. So from this vertical plane, this distance of point A, it has not been defined. So we can choose any appropriate distance corresponding to the point A. But one thing is for sure, that is wherever point A dash has been located, onto the same vertical line projection over here, point A will be located over here. Similarly, wherever point B dash has been located in the front view, onto the same vertical projection line, the location of the point B we can identify or locate in the top view projection. Now, since we have assumed an arbitrary distance from the vertical plane corresponding to this point A, so once I extend this line, we will find that the point A will be located in the top view at this particular position. So as we have said that this distance is an arbitrary distance because this distance has not been defined. Distance of point A from the vertical plane has not been defined. So once we locate point A over here, another thing we know from the statement that the distance between orange A and orange B measured along the wall, it is equal to 2.6 meter over here. So this distance of 2.6 meter will translate to 52 millimeter in the top view. So we can see that this is the location of point A or the orange A or the object A from object A alongside the wall. You can see this is the wall. So alongside the wall, the distance between point A and point B or the object A and object B, this distance happens to be 52 millimeter. The moment we mark this distance of 52 millimeter, you can check alongside this locus line at a distance of 2 meter on the right hand side, we are going to get the top view projection of the point B over here. So point B will be located at this particular position. So similarly, I extend this vertical projector over here at a distance of 2 meter on the right hand side at a distance of 52 millimeter or 2.6 meter from the point A. We can see distance is 2.6 meter from point A measured alongside the wall. So alongside the wall, we have measured the distance of 2.6 meter. Over here, we'll be able to obtain the coordinate location of the point B in the top view. So point A coordinate in the top view has been obtained. Point B coordinate in the top view has been obtained. Now we are going to join point A with point B. So these are the apparent length projections of the line in the top view. So this is also apparent length. This is also apparent length. Now we have been successful in converting this particular real life environment problem into the orthographic projections of an oblique line. So here we can see this is an oblique line AB in which A dash B dash, it is inclined to HP. AB, that is the top view projection, it is also inclined to HP. So none of these projection lines, they are parallel to the XY reference line. And we are going to get apparent length projections in the front view as well as in the top view. Now, having obtained the projections of this particular line, now we are going to use the principles of rotation of the line in order to obtain the true length of this oblique line in the front view as well as true length of this line in the top view alongside their inclinations with HP and VP. So in order to obtain the true length of the line in the front view, we remember the principles of rotation of line, that is, whenever the apparent length projection of the line in the plan or in the top view, they are parallel to the vertical plane, so their corresponding projections onto the vertical plane, that is in the front view, they will be revealing us the true length or true shape of the line. So here we have got the apparent length projection of an oblique line which happens to be inclined to the vertical plane. So now we are going to rotate this apparent length with respect to this point A over here. So point A will become our needle point of the compass or the locus point, and will open the compass is equal to the distance AB and rotate this plan projection line in such a way that after the first rotation, this apparent length which was available with us in the plan, it becomes parallel to the vertical plane, and after the rotation the point which is obtained is B1 because it is the first rotation. So having obtained this apparent length parallel to the vertical plane, we can see over here, this is the apparent length which is parallel to the vertical plane. So projection will be drawn through this point up to the second point of the elevation over here, that is up to the point B dash locus line. So this is the locus line corresponding to the point B dash in the elevation. So from B1 I am going to draw a vertical projector. We can see the orientation of this particular line over here. So once we extend this line up to the locus line corresponding to the point B dash, so the intersection of these two lines, it is going to provide us with B1 dash point in the elevation. The moment we obtain this B1 dash point in the elevation, now we need to join A dash with B1 dash, and we are able to obtain the true length of the line in the elevation or the front view. So having obtained this true length of the line which has been shown with blue color so as to distinguish it from the apparent length. Now having obtained this true length, now we can evaluate the angle of inclination of the true length of this line with respect to the horizontal plane, and this angle will be marked as angle alpha over here. Now having evaluated the true length as well as the true inclination of this particular line in the front view, now we want to evaluate the true length of the line in the plan. Now we know that in order to evaluate the true length of the line in the plan, our apparent length projections in the elevation, they should be parallel to the horizontal plane. So only when our apparent length projections in the elevation, so they are parallel to the horizontal plane, so onto the horizontal plane, that is in the top view, we will be able to obtain the true length of the line over here. Now here we have got the apparent length A dash B dash in the elevation. So these are the projections available with us in the front view. Now these projection A dash B dash, it is not parallel to the horizontal plane. So what we have to do? So we have to rotate this apparent length elevation projections A dash B dash with respect to the point A dash over here, such that this elevation projection should become parallel to the horizontal plane. So with A dash as our needle point, we are going to open compass is equal to the distance A dash B dash, and we will be rotating this elevation projection line A dash B dash in such a way that it becomes parallel to the horizontal plane. So after the rotation, the name of the point which is available with us will be B2 dash. So now we can see that this apparent length elevation projection A dash B2 dash, it has become parallel to the horizontal plane, and once our elevation projection becomes parallel to the horizontal plane, now its projection onto the horizontal plane will provide us with the true length of this line into the plan. So from here I am going to drop a vertical projector line up to the locus line corresponding to the point B. So this is the locus line corresponding to the point B, which is already available. From B2 dash, once we draw this vertical projector, we can see the direction of construction of this particular line. So once we move along this line and it intersects with the horizontal locus line corresponding to the point B, so point B2 will be obtained over here. So having obtained this point B2, now we are going to join point A with point B2 using a blue color line. So blue color indicates it is a true length. So now we have been able to obtain the true length of the line in the top view. The true length of the line in the front view has already been determined. So once we evaluate that A dash B1 dash distance, that is true length in elevation, it should be equal to true length of the line in the plan, that is AB2. So if A dash B1 dash, it is equal to AB2. So then we can conclude that the construction that we have made, it is an accurate construction and we have followed the principles of rotation of line in the appropriate manner. Now having obtained this true length of the line in the plan, now we can mark this angle of inclination of this true length, that is AB2. So we can mark this orientation of this line with respect to the vertical plane. So this angle of inclination of the true length or the blue line with respect to this particular locus line, that is with respect to the vertical plane. So this angle will be termed as angle phi. So we have been able to evaluate the true length of the line in the elevation, the true length of the line in the plan, inclination of the true length of the line with respect to the ground or the elevation, inclination of the true length of the line with respect to the vertical plane. All these aspects, they have been evaluated with respect to this particular string which is going to join these two objects or the oranges over here. So once we have validated that the true length A dash B1 dash, it is equal to AB2, that is the true length in elevation, has been found to be equal to true length of this string in the plan. So it means that the construction is accurate over here. So this way we have been able to convert this situation into the orthographic projections of the oblique lines, and we have been able to obtain the true length and true inclinations of this oblique line using rotation of the line method. So this is all for today. So we will be proceeding with further discussion regarding few more cases of projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.